Our book is, it's like chapters. There's like 8 or 9 that we cover. I think it goes through chapter 8, but we obviously had like the review chapter, whatever that they have, so I think it ends up being 9 total. So, but I'm not like forced to get through all of it. So like last year I got through a ton, but if I don't get through, like I had like extra time at the end of the year because we got through so much. But that just depends, like year to year is different with every class too. So, and that was the first time I taught it, so I went like super fast through some stuff that I like could have like slowed down on. So it just depends. All right, so now we're still solving equations, but now they're going to involve square roots. So how would we undo a square root? Like, what's the opposite of a square root? Yeah, square it. So 46, we've got x minus the square root of 3x plus 18 equals 0. Now, this is where there tends to end up being a problem. People decide right here that they're going to square both sides, because remember, what you do to one side, you have to do the other. That's a problem, because what that means is that I'm then squaring x minus the square root of 3x plus 18, and that does not give me what I want. So I need to move everything over first that doesn't have the square root before I square both sides. So I'm going to subtract the x over. So I've got negative square root of 3x plus 18 is equal to negative x. Then divide by the negative, so the square root of 3x plus 18 is equal to x. Now, because I have the square root, on the side by itself, I can square both sides. So, squaring that, I'm squaring that. And so the square root and the square cancel, so I'm left with 3x plus 18 over here is equal to, over here, x squared. And so then now I'm solving the equation, so now it's basically, that step is the new stuff. Now here on out, it's what we were doing at the beginning of this section before. So I'm going to move this stuff over. So 0 is equal to x squared minus 3x minus 18. And now I just need to factor and then use the zero product property to solve. So what would x squared minus 3x minus 18 factor into? Or what are factors of negative 18 that add up to give me negative 3? Negative 6 and 3. So that'll be x minus 6, x plus 3. So then now I just split it, set each piece equal to 0. So x minus 6 equals 0, x plus 3 equals 0. So then x equals 6 or x equals negative 3. So obviously can't be both at the same time. So the only new stuff is this first little chunk here, and then once we get to that, we're just back to normal solving and factoring. Let's see, 50. The square root of 6x plus 7, and then outside of the square root minus 9 is equal to x minus 7. Alright, so before I do anything, before I square both sides, I should say, I need to move that 9 over to get the square root by itself. So the square root of 6x plus 7 is equal to x and then negative 7 plus 9, so that's going to be plus 2. Now, square both sides. So then 6x plus 7 is equal to, so now remember this is like x plus 2 times x plus 2. This isn't x squared plus 2 squared, okay, because that's what a lot of people tend to do. That's why I put parentheses around it to square the whole thing. So this is going to become, this is a perfect square trinomial, so x squared plus 4x plus 4. Then I'm going to move this stuff on the left over to the right. So 0 is equal to x squared minus 2x minus 3. So then factors of negative 3 that add up to give you negative 2. Yep, x minus 3 and x plus 1. And then set each piece equal to 0, so x minus 3 equals 0, and x plus 1 equals 0. So x equals 3, or x equals negative 1. All right, so this next problem that I'm going to do, it's the same principle, but it gets a little harder because I now have a square root on both sides. So 56, we've got the square root of x plus 5 outside plus 2 is equal to the square root of x minus 1. So now I still need to square both sides, but I have to be really careful because now since I have a square root on both sides, I can't just like move that 2 over or something like that and then make life easier. So now this is where the parentheses get really important because I'm squaring this whole thing, okay? So this is like the square root of x plus 5 plus 2 times the square root of x plus 5 plus 2, okay? And then over here, we're squaring this one, so that one's just gonna, square root's gonna go away. So, over here, I'm gonna write this way so that we can see it and work through it, but. So, the square root times the square root, okay, just gives me x plus 5 because that's basically just like squaring it. So we have x plus 5 plus, I have 2 times the square root of x plus 5, and then over here I'm going to also have 2 times the square root of x plus 5, so that's going to be 4 times the square root of x plus 5. And then lastly, the 2 times 2, so that's going to be plus 4 equals, and then over here, square root goes away, so I'm just left with x minus 1. So now I'm going to simplify stuff and then move stuff over. So I basically got x plus 9 plus 4 square root of x plus 5 equals x minus 1. So then if I subtract the x's are going to go away. They cancel each other out. And then 9, or 1 minus 9 is, or negative 1 minus 9 is going to be negative 10. So I basically got 4 times the square root of x plus 5 is equal to negative 10. And if you wanted to, you could go ahead and divide by 4. I'm going to leave it. It really doesn't matter. But so now we have to do this process again. Okay, because I still have a square root. So I've got to square both sides again. So square, square. So now over here, 4 squared is 16. The square root squared just becomes what's inside. So 16 times x plus 5 equals negative 10 squared is positive 100. So then divide by 16. So x plus 5 is equal to 100 over 16, which I can reduce down to be, I can take out a 4 from top and bottom. So x plus 5 is equal to 25 over 4. And then I can subtract the 5, but since I want a common denominator, okay, 5, if I want a denominator of 4, I need to multiply the 5 by 4. So that's going to become 20 over 4 when I subtract it. So x is equal to 25 over 4 minus 20 over 4. I got that from there, or to go there. So then x is equal to 5 over 4. And so this one ends up only having one answer by the time it's all said and done. So this one, most of the time, you end up having to go through the process twice just because of how it works out. But anyways, those ones tend to be harder and people tend to struggle with them. So I like to show you how to do them in case they ever come up. But I try to avoid them on quizzes and tests if I can, just because people end up losing things in the process. And it's not that they don't necessarily know how to do it. It's just that pieces get lost and they don't end up doing well. So I'm not going to say with 100% certainty you won't have one of these, but it's much less likely than the ones that we did initially. All right, and then let's see. The next one still say to solve the equation, but they give us our exponent as a fraction. So 76x to the 5 over 4 is equal to 32. So it's probably been a little bit, but do you remember what an exponent that is a fraction, what the numerator represents?
Oh, that's the so the root of or whatever. It's like the
So is 5 or 4 the root?
4.
4 is the root. And then 5 would be the
Like the square part.
the exponent part, yeah. Well, I guess I shouldn't really say exponent. I guess I should say the power.
Yeah.
The whole thing's kind of the exponent. So I need to undo that, okay, in order to get x by itself, because I'm still solving the equation, which means I need to get x by itself. I will always undo, well, I don't want to say always. 95% of the time, I will undo the power first. So if I am being raised to the 5th power, to undo it, I would need to do what? Yeah. Yep. Take the 5th root of it. So I'm going to take the 5th root of both sides. So that means that on the left, I'm left with x to the 1/4.
2.
Yep. The 5th root of 32 is 2. So now the 1/4 means I had taken the 4th root of that. So if I want to undo a 4th root, I would need to do what? How did I undo a square root?
Power of 4.
Yep, I'm going to raise it to the power of 4. So I'm taking everything and or both sides, I guess, and raising it to the power of 4. So on the left, I'm now left with just an x. 2 to the 4th is what? 16. So if you had wanted, say, we did this technically in 2 steps, if you had wanted to do this in like 1-ish, if you had x to the 5/4 is equal to 32, we could have said x is equal to the 5th root of 32 raised to the 4th and written it like that. In reality, it's not really any less writing. This way helps you see better what's happening, but I don't care which way you do it. We would have gotten to the same conclusion either way, that it was equal to 16. Let's look at 80 really fast, and that'll be our last one. You could. X plus 200 raised to the 2/3 is equal to 36. So what should I do first in this one? So I've got it raised to the 2/3, okay?
Do the third, or the 3, whatever it's called.
So you want me to cube it first?
Yeah.
Or you want me to take the square root first?
Whatever one's better.
I would say the square root, because
Yeah.
I don't know what 36 cubed is, but I do know what the square root of 36 is.
Yeah.
So I'm going to take the square root of both sides first. So x plus 200 raised to the 1/3 is equal to 6. So now, not that I'm still expecting you to know what this is, but might be a little easier. So now I need to cube both sides. So I'm left with x plus 200 on the left. Now,
216.
yeah. Save me some work. So then we need to subtract the 200 from the left. So x is equal to 16. 16 must have been the popular number for this section. All right, any questions about those? Anything? All right, so then problems are going to be 45. Oh, no, not 50. 45. There we go. 49. 59, which this one has a square root on both sides, so I want you to just, like, do your best on it, but worry more about 45 and 49. And then 75 and 79, which would be like what we just finished doing here in 76 and 80. And you do need, I think there were notes for 1.7, pretty sure. You do need to make sure you have those done for tomorrow. So.